When astronomers first catalogued an object known as 3I Atlas in July 2025, almost no one paid attention. It seemed like just another interstellar visitor, a piece of debris drifting through the vast emptiness between stars. It was only the third object of its kind ever observed passing through our solar system, but at first glance, it appeared ordinary. A silent traveler on a one-way journey. Everything changed when the James Webb Space Telescope focused its instruments on it. What researchers found was unexpected. This was not just an icy object warming as it approached the sun. Deep within it, something appeared to be generating heat. Not randomly, but in a steady, repeating pattern. The internal glow pulsed at regular intervals, almost like a rhythm. Over time, this unusual behavior became more difficult to ignore. Instead of fluctuating like typical comets or asteroids, its brightness remained strangely consistent. More puzzling was the discovery that the heat seemed to come from inside the object rather than its surface. Every 4 hours, instruments recorded a rise and fall in thermal energy, repeating with remarkable precision. Scientists initially described it as a thermal anomaly. Informally, some began referring to it as something resembling a heartbeat. As observations continued, radio telescopes around the world joined the effort. Facilities including the Allen Telescope Array began scanning the object for signals. After days of silence, a faint but consistent radio pulse was detected. It repeated on the same 4-hour cycle as the thermal pattern. At first, researchers suspected interference or natural cosmic sources. However, repeated observations confirmed that the signal was stable, narrow in frequency, and highly structured. Analysis showed patterns that did not match known astrophysical phenomena such as pulsars or background radiation. Further investigation revealed something even more unusual. The signal showed slight variations that appeared to correlate with changes in the solar environment. It was not only repeating, it seemed responsive. Attempts were made to compare the signal with known natural sources, but none matched. Eventually, a simple test transmission was sent back, consisting of basic mathematical patterns such as prime numbers. After several days, a faint return signal was detected. It aligned precisely with the expected timing window. This raised serious questions, though no official conclusion was reached. Soon after, another development drew attention. Observations indicated a small but measurable change in the object's trajectory. Instead of following a purely gravitational path, it appeared to adjust its course slightly, moving closer to the plane of the solar system. Models suggested that natural forces like outgassing could not fully explain the shift. The amount of force required was greater than what typical comet activity could produce. At the same time, a sudden increase in brightness was recorded, suggesting an internal release of energy. The timing of this flare coincided with the trajectory change. Spectroscopic analysis provided additional data. While common elements such as water ice and carbon compounds were present, there were also unusual signatures that did not clearly match known natural materials. Some readings hinted at complex metallic compositions, though the results remained inconclusive. Meanwhile, researchers studying the object's emissions noticed that it behaved like a resonant structure. Signals across multiple wavelengths appeared to interact in a coordinated way, producing repeating patterns. When these signals were processed and visualized, they showed structured forms that resembled organized data rather than random noise. However, interpretation remained highly speculative. Later observations using infrared imaging revealed what appeared to be internal structural variation. A region within the object showed consistent motion, though the resolution was not sufficient to confirm its nature. As observations of 3I Atlas continued, the scientific community shifted from surprise to cautious analysis. The earlier anomalies, thermal pulses, structured signals, and subtle trajectory changes, remained unresolved, but researchers began focusing on one critical question. Could all of this still be explained by unknown natural processes? Teams working with the James Webb Space Telescope refined their infrared imaging to study the object's internal heat distribution in greater detail. What they found was complex but not necessarily artificial. The internal heat variations could, in theory, be caused by layered materials with different thermal properties, slowly releasing energy absorbed over long periods in interstellar space. At the same time, the radio signal detected earlier continued to be monitored by facilities like the Allen Telescope Array. While the signal remained consistent, deeper analysis suggested it might be the result of resonance effects, natural interactions between charged particles, magnetic fields, and the object's irregular structure. Some astrophysicists proposed that the apparent response to human transmissions was coincidental timing rather than true communication. In highly complex systems, patterns can emerge that appear meaningful even when they are not. Attention then turned to the reported trajectory shift. New simulations showed that under certain conditions, uneven outgassing combined with rotational dynamics could produce small but measurable changes in direction. While rare, such behavior has been observed in comets before, though not with this level of precision. Spectroscopic studies also became more refined. The unusual material signatures that initially suggested exotic or engineered compounds were re-examined. Scientists found that extreme conditions in interstellar space, cosmic radiation, pressure, and temperature over millions of years, could potentially create unfamiliar molecular structures that mimic more complex materials. Meanwhile, discussions around the object's internal structure grew more grounded. The spiral-like motion seen in earlier imaging was reinterpreted by some researchers as a visual artifact caused by rotating jets of gas or dust interacting with uneven surfaces inside the object. Even the surface movement observed in earlier data found a more conventional explanation. Changes in light reflection, combined with rotation and irregular geometry, can create the illusion of shifting panels or openings when viewed from great distances. The comparison to the WOW signal was also revisited. While the timing and frequency overlap were intriguing, experts emphasized that many cosmic signals can coincidentally resemble each other when filtered and processed in different ways. Perhaps the most important development was a growing consensus around uncertainty. Scientists began to publicly stress that while the object displayed unusual characteristics, none of the observations definitively pointed to intelligence, life, or artificial origin. In fact, many argued that jumping to such conclusions could distract from the real scientific value of the discovery. Interstellar objects like 3I Atlas offer a rare opportunity to study material formed in entirely different star systems. Every anomaly, no matter how strange, could expand our understanding of physics, chemistry, and cosmic evolution. There were still unanswered questions. The regularity of the thermal pulses remained difficult to fully explain. The stability of the radio signal was still under investigation. And the object's long journey through interstellar space raised new questions about how such bodies form and survive. But science does not move forward through assumptions. It moves through evidence. 3I Atlas remains under continuous observation. New data is being collected, models are being refined, and hypotheses are being tested. For now, what once seemed like a possible encounter with something alive has settled into something equally powerful. A reminder that the universe is far more complex than our current understanding.